and there is a limit to it. Space heating, we can eliminate the need by building the house properly, and that's why I'm a passive house fan, as you would probably guess. You can take that and practically remove it. Lights and appliances, you can improve it again, but depending on what you do in your lifestyle, if you're running a machine, it needs power. So, and this is the bit that's grown in the last few years. These have stayed relatively stable. People don't require themselves to be much hotter, and they don't require much more hot water. So they have stayed relatively same, and the increased use has been sort of counteracted a bit by efficiency. That bit has grown like topsy, plasma tellies, computers, etc. So be aware that the different forms of energy can be reduced in different ways. Okay, very quickly, I've broken it into 4 bits. The middle bit, where the emissions come from. Embodied energy, building the house, materials, labour, etc. Next bit, the regulated emissions. This is what SAP deals with. Heating, lighting, pumps and fans. The sort of fabric of the building itself. This is the building's energy use. Unregulated emissions, lighting, cooking, appliances that are affected by what you do. And the outside that, lifestyle emissions. Where is that house? It's on the top of a mountain. You're going to use a lot of energy. It's not related directly to the house, but because you put a house on the mountain, you're going to burn a lot of fuel. Yeah? So you need to understand that there are different areas of energy. If we look at what those things I've been talking about deals with, SAP deals just with that, regulated emissions. The heating, lighting, pumps and fans. It doesn't deal with lighting, the other non-fixed lighting, cooking and appliances. It doesn't deal with what you build the house of, doesn't deal with where it is. It's just interested in that. Code deals actually with a bit of all of it. Because it's SAP driven, it obviously deals with that in spades. But it also looks at materials and how you construct the building, so it deals a little bit with embodied energy. It also it does look at white goods, what sort of white goods you're putting into your house, so cookers, your washing machines, so it's dealing with some of this as well. And it does touch on lifestyle. The old eco homes used to worry about where the nearest post office was. Code doesn't, but it does have things like I'm trying to think of a good example now. We'll touch on that when we get to code. Passive house deals with 2 bits. It deals with energy only, but it deals with all the energy directly related to the house. So it deals with the regulated emissions, but also things like cooking and lighting. So the major part of your energy demand. Yeah? Everything that was in that big circle, it deals with. It doesn't deal with embodied energy. It doesn't give a toss what you build the house out of. And it doesn't deal with where it is. Okay. Now there are 2 ways you can approach this, and this is what is known as the fabric first approach. You can sorry, we'll come to the fabric first approach. You can build a house to meet the building regulations. Yeah, it's fine. Like a lot of the houses you'll see around here, they meet the building regulations. On paper, if you tested them, that might be a different matter. Paper, they meet the building regulations. And then you can say, we want to reduce the emissions, we'll add some technology. So you've bung on eco-bling. So you can have a higher energy house with low emissions because you've bunged on a lot of eco-bling. Nice solar thermal panels, they will work quite well. They're about the right size for this house, if it's a sort of 3-4 bedroom house, and they look like they're in the sun. A very tiny PV panel, which is too small to power a telly, and it's got a shading bit here. Well, when that panel will not be working, because if you knock out a bit of a panel, the whole string goes down. And I won't even mention the propeller on the roof. You know, you've got to be 10 metres above the roof.
Is that David Cameron's house?
Sorry?
Is that David Cameron's house? He's got
Probably.
a propeller on the roof.
Yeah, I think he's taken it off now. Now, you've built this house, and you've spent all the money on kit, and the kit fails, your emissions go back up through the roof again. It requires maintenance, it requires replacement after 10, 15 or 20 years. Houses last 100 years plus. Okay, that's the technology approach. Or you take the energy and emissions reduction by fabric approach. You build the best possible envelope you can. You spend the money once, you spend a bit more money. That is Denbydale Passive House. 3rd passive house in the UK, masonry construction. Doesn't look particularly different from a lot of other houses around it. Slightly more modern. You then add the minimal services to service that house. So you've already reduced the demand. You don't need as much kit anyway. and you just put on what you need, you're building savings in for life, you haven't got lots of technology to fail, and the extra cost on fabric may be, come in, may be quite small, okay? Now, that has, the PV on that is probably a retrofit because they were going to get lots of money off the government for putting it on. The solar thermal probably was part of the original design. But that house doesn't need that PV to be very low emissions. So, sustainability is not absolute. It's what you decide it is within the parameters that you draw. Energy efficiency and emissions, energy and emissions are linked, but they're not the same thing. And I would suggest most people in the green building, everybody in green building, most people in building would suggest fabric first. Because if you build fabric first, you're actually reducing demand permanently. Okay? Any particular questions about that before we move on to the three main areas of... No? Happy with that?
Just a comment, I really like the fabric first. That's what I think part of this is about, really.
To be honest, if you don't go for fabric, you know, you've not got the message. It's no brainer. So.
Yeah. One quick question. How much? I don't know. I didn't know anything about passive house before joining the group.
Yeah.
And I've heard various things about the thickness of walls and things.
Yeah.
But the picture you showed a fairly standard, possibly uninspiring house, but it's a passive house. It's very familiar. Does it need? Do you lose a lot of land to have 6 foot thick walls?
You need thicker walls.
Yeah, but how much?
You need thicker walls. Go and buy a country cottage, you'll get walls anything up to 1 metre thick, right?
Yeah.
The last 50, 60, 70 years we've been building cavity walls 250, 300 thick. We've got used to 300 walls. A lot of designers and architects build, they just draw 300 walls. You need to design a passive house with a 500 wall. You may be able to reduce on that. But if you start with 500 wall, you can do it.
Tell you what improves the light though. If you go into thick wall buildings, you get the most amazing light because you've got these deep reveals, rather than having like a little cut through with a cardboard. If you hold that up to the sun, you get black and you get white. If you've got a bit of depth, you get the light reflecting off the inside. So if you think about like an old church where the reveals come back, yours gets amazing sort of graduated light. So there are positives as well as you lose a bit of space, but you gain quality. I think thick the light.
And on that, I mean, that house or the house you showed had quite a few windows on the south-facing side, I guess. Because windows haven't got as good a thermal insulation as...
We'll come to that.
Right.
We'll come to that.
Can I say one last thing, just about the space it takes as well?
Yeah.
Because you've actually got quite a large site, the space doesn't have to come off the inside of the building.
Yeah.
It can come off the outside,
Yeah,
so it doesn't necessarily affect your living space, but it might affect the size of your garden. But if you're talking about having shared garden space, then perhaps the size of your private garden. I'm just saying.
No, I agree.
Factor. And by having the buildings sharing party walls, as I think has already been discussed and more or less agreed, you vastly reduce the amount of footprint of the walls taking up anyway, because those walls don't have to be 500 feet. So.
Exactly.
Nice thin wall you can use in neighbours.
Passive house, you don't need it anyway. Okay. Right, let's take a quick gallop through the building regs. Okay, there it is. That's what you're going to be dealing with. Part L1A, conservation of fuel and power in dwellings. The main sort of thrust of this document is to limit carbon emissions. Okay, and it does it by saying that we had a version in 2000, we had a version in 2006, and we had a version in 2010. We're going to get some new ones eventually later this year, and in 2016. They've been delayed this year, which is a pain, but there we go. They essentially set limits on design. And what they say is, go away and get your SAP calcs done and make it better. So we'll come on to how that works in a second. But that's the document, Part L. It is the UK-approved calculation method, shows compliance, there you go, 2000, 2005, 2010, new one coming through 2013. It calculates energy use and then converts it to emissions. All right? So it works out the energy status of the house, and then works out the emissions depending on the fuel you're using. It also produces the EPC, the Energy Performance Certificate you will have to have. It's a two-stage process actually, producing sort of predicted energy one first, but there you go, that's compulsory. The building control people will want to see those calculations. You need to understand two terms. The first one is DER, which is the dwelling emission rate. Now this is the emissions that SAP calculates your design will produce. The dwelling emission rate. Think of it as design emission rate, if you like. The second thing is the target emission rate. And what SAP does is it takes your building, it ignores a lot of the things you've put in and says, I will apply the minimum standards of insulation and air tightness and equipment, and I will calculate the emissions for this notional house, and then add an improvement factor. So in 2005 they said 25% better than 2000. So it would calculate the emissions, let's say that's 10 tonnes, and then it would say, right, we want a 25% improvement, knock a bit off, you've got to produce 7.5 tonnes and no more. So it's a notional calculation within SAP that tells you a target you've got to meet. And if you don't meet it, you're not complying with the regulations. Then in 2010, they put another chunk on it. So we're now at 44% improvement over 2000, because it was another 25% on an already reduced target. And it will continue to get tighter. And the plan was that in 2016 it would be zero carbon. That was the plan. It only deals with regulated emissions. It's not bothered about your telly or your fridge or any of the other electrical toys. It's bothered about your heating, your lighting, your hot water, ventilation. And I say lighting, fixed lighting. Unregulated cooking and other lighting appliances are not included. And it's measured in kilograms of CO2 per metre squared. So it's a metre square of floor area. It does it by calculating heat losses through fabric and ventilation, measuring heat gains, losses from devices, energy demands, creates this carbon emissions DER, and calculates this target rate. So it does, we calculate this, all the way through, and we end up with some numbers. Now that is a screenshot of the results sheet of a SAP calculation. This is, and so you can see what information it gives you. It gives you a rating, you know, the old coloured bands like on your fridge, A to G. So it gives you a rating. This is a social housing property we've designed to Passive House standards. So it's a 93A SAP rating. That could go up to 120 because they started with a 1 to 100 scale and then realised that zero carbon homes, they've got to go higher. So it's like 11 on the old amplifier on Spinal Tap. And it has a thing called the environmental index, which is actually a CO2 thing. I don't know why you've got the 2, 90B. It tells you what your emissions are. So our emissions from this house, putative house, are 2.2 tonnes per year of CO2, 9 kilos per metre squared.
To put that in context, the 2.2 tonnes, what would a sort of a Victorian terrace of a similar size be?
10.
So it's about 4 times better.
Yeah, probably better than that actually. Don't take these as absolute values. They're just a screenshot of one house.
It's that sort of scale.
Yeah. It also tells you here is this TER. This is the target that the SAP calculated got to hit, 17. And you can see we're coming in at 10, so we're well under. And that's our improvement level, 37%. It also tells us what we can put into code, because it generates that automatically for us now. So you can see this was a level 4 house, not 3 or 4. And these are credits under code. And it tells us about this thing here called fee, which is not yet, it's only used in code, but it's coming into regs, the fabric energy efficiency. Finally, we're getting an energy standard into buildings. Finally. And it tells us what we get for low and zero carbon technologies as well. That's a biomass heated house with yes it has, it's got PV, sorry. You can see here. This is the NEGR assessment from which SAP was derived. it tells us more because it actually deals with the unregulated and it works out costs. Now this figure, this SAP rating, is related to cost. It's how much your fuel will cost. So if you put different fuel in, that will change. All right? You don't really need to know the details, but that's roughly how it works.
What's the difference between main and secondary heating?
Main heating is your main central heating system. Secondary heating might be electric fires or a wood burner. Right. Okay.
And that was a big house. Well, it's little relatively, 200.
It'll be a 3-bed, yeah, about 90 square metres. Not a huge house, that one.
Oh, I'm confused then. Can you go back?
Yeah.
So the emission rate is 9 kilograms per metre. No, per metre squared. So if you've got a total, so if you divide 2,260 by 9,
yeah, that's a very good point.
you get
What's going on there?
200 plus metres squared, which is a fairly big house, I would argue.
Pass at this stage. I'm sorry, I don't know the reasons why that. I just grabbed a screenshot and I didn't check the
But
numbers.
if that's a fifth of a typical Victorian terrace, that's really good. If it's a big house and it's...
Not as big as that. I have to gloss over this one. Sorry. You've also got to be very careful about these numbers. Look, you see here we've got 18 because this is dealing with unregulated. But there is one thing about SAP I'm just about to tell you is it's notoriously unreliable. You've got to be very careful about using SAP numbers. You shouldn't use it as a design tool, but we do. Anyway, how it works? Sorry, it calculates the area. We calculate all the area of the. We calculate how big the house is. We enter that in. We put in all the services and everything in, and then the software grinds through this huge calculation, huge sort of sum. Works out heat losses and gains, works out the energy demands, works out the emissions, works out the cost of the fuel, converts that to a SAP rating, and then it also gives us code credits. So that's just what SAP does. The problems with it are, it's not very accurate. Okay? It has some poor features. It doesn't work geographically. So if you build a house in the north of Scotland or in Cornwall, it gives you the same result, because it's based on weather data in the Pennines, average Britain. It's got limited options. You can't put some stuff in. If you build an off-grid house with a wood burner, can't cope with it. So I have to do SAP calcs for those sort of properties and then talk to the building control officer and say, you can't put this into SAP. You can't put that into SAP. He says, yeah, I know. Okay, pass. If you treat it relatively, comparing house to house, okay, but don't treat it as absolute. Please do not believe the numbers that come out of SAP. They're not accurate. It's not good on overheating, which is a big issue with the future climate change. If it gets warmer, we need to keep our houses cool. They don't want us to put in air conditioning in. It has anomalies with very low energy buildings. It doesn't work at the extremes. It doesn't like passive house very much. And there's no post-hoc convincing monitoring to speak of that's checking it. It's all forecasted, predicted, smoke and mirrors. But that's my message about it. You know, don't worry-o. There are other things we can do. I won't spend too long on this, SAP is. I just wanted to introduce you to that so you know it's there, you're going to comply with it. All right, any major questions on SAP? I'm aware of time. Okay. Let's talk about the code. You may be told to do code, you may elect to do code, but you need to know what it is. It's an environmental assessment method for rating and certifying the performance of new homes, and that's what they said about it when they launched it in 2006. A step change in sustainable home building practice. Well, it is government speak, but okay, yeah, it's far better than some of the things. We didn't really have much before. We had eco homes, which was pretty clunky, and code was developed from it. And it's the only standard, environmental standard of all the ones in BREEAM and stuff that is known wholly by BRE. So that's a good thing, though they do administer it. It looks at broad sustainability. If you remember back to the energy circles, it covers a bit of everything. So they break down into these 9 issues. Energy, water, materials, surface water runoff, flooding, which is a bit of an issue around here, waste, pollution, health and well-being, management, you'll see what that means, and ecology. The reason I asked you what was on your site is if that was pasture, it's of high ecological value potentially. If you're going to, you probably have to have an ecological survey anyway. If it was concrete and there was nothing growing on it, then it's of no ecological value. Anything you're going to do is going to improve it. You get lots of points, but if you're taking over a meadow, it's going to be harder. It's important to know what's going on. So those are the issues. These are the points and credits. What happens is you get points on each issue as you score it, but they're not related to each other, and then they take the whole lot and they give them weightings so that they're then related to each other, and you end up with, give credits and you end up with points. This is the energy section, and what you can see is that 36.4 of your final score is in this energy section. Over a third is to do with energy and emissions. And bits like pollution, 2.8%, 2.2% is that. So these are of different value. They're not all of the same value. Okay?
So, because I noticed there on materials,
yep,
you get 24 credits.
24 credits, but they're weighted at 0.3, so they're only worth 7%.
Okay.
What they do is they say, how are we going to score this one? Oh, we need to score this on a 1 to 10 ratio.
Oh, but it's up to a 1 to 24.
Yeah, so here we've got actually, there's a 1 to 15, there's 24 points. There's one bit which is, you'll see it in a minute, but basically you score it, but it's not related in value, and then they put a value on it. So these are...
So what we should be comparing is the light blue score.
Yeah, the light blues are the
points.
scores. Yeah. Sorry, I've lifted this from a presentation I do on code, which is slightly more detailed. But here's the value. This is what you're really looking at. This is your code cake. So here's energy. Yeah. Here's water. Materials here. This is ecology. You can see the big ones are energy, ecology, management. Health and well-being is quite important. So having a nice house to live in and one that will last you. Whereas down here, 2.2, that's surface water runoff and that's materials. So it's not very, very concerned with materials, what you build it out of. Out of interest, the average house 5 years ago would have about 25 tonnes of carbon embodied in it. Build it out of timber, it would be down 6 tonnes. Build it really well out of timber, and it would be down to 2 tonnes. But the average house then was putting out 6 tonnes a year in carbon, so over 100 years, 600 tonnes. The embodied energy compared with the lifetime energy is very small. Okay. If you're on code 4, that's where you are. You've got to get 68%. You're only on code 3, 57. Level 5 is 84 and level 6 is 90, and believe you me, that's tough. It's tough to get a level 6 house through. I'm currently working on one at early stages. Everything out in the country, earth sheltered, passive house, loads of PV. It's got everything. It's more sustainable than you could imagine in conventional terms. We get about 91.5 is the best score I can get at the moment assessing that house. It's really tough to do code 6. If you choose to do code, you're taking on a load. There are some mandatory things in code you've got to do. Okay? You don't get any credits for them. You have to do a little bit about your materials. You have to put a certain amount of materials that meet a certain